Welcome to AQA AS Chemistry, and today we're going to be doing a video on the polymerization reactions and their properties. So first of all, there's two types of polymers. There are addition polymers and there are condensation polymers. So addition polymers are made in the reverse process to cracking, and it's where alkenes add to each other to extend the carbon chain. So you have, initially with polymers, you have an initial monomer group, and what polymers are really are just they're many units. There are many versions of the same unit. It's just a repeating unit. So, for example, if I had a unit, for example, that if you were asked to represent, let's pick polyethene. So the monomer for polyethene will just be ethene, and how it represent that is in the broken state. It'd be in the monomer state. When I mean broken, I mean the double bond is broken because and you put an N here. So this double bond is broken to allow bonds either side of each carbon atom, and this is what allows to have the repeating unit. So this is just one unit of ethene, and I have a repeating unit. Let's just do 8 units. 8 units of this group. So you see, I can do this an infinite X amount of times, theoretically at least. But the point being is that you understand that this is just it's just the same unit being repeated over and over and over again. Now these are obviously millions of atoms long in reality, but if I was just to go and that continue there, and that continue there. But the most important is that you just get that that's one unit, another unit, another unit here, and then this can go as much. So in this case, the repeating unit would be 1, 2, 3, and 4. So the N would represent 4. Let's go and actually see what polymers. Let's actually go into these about polymers. Polymers, it's in the word here, poly. Oh. Polymers in itself is, well, poly in Greek means many, and then polymers will just be molecules, so you have many units. So it's just many. When you're talking about polymers, we're just talking about many repeating units. So as I said, polymers are made up of repeating units called monomers. So the simplest polymer is polyethylene. Is also called, also known as polyethylene or polyethylene. Polyethylene is essential. It's essentially one very long alkane chain for ethene. But it looks like an alkane chain when you look back at it here. It does look like a massive alkane chain. But technically, you have to remember that this bond here is broken. Double bond here is actually ethene, but the double bond is broken to allow the bonds to happen. This doesn't. You can't do this with alkanes because you can't have the extra bond really. And it's not really a polymer. It's just an extended alkane really. When you're having polymerization, it's going to be with alkenes. We're talking about addition polymerization because the bond's going to have one repeating unit. The double bond breaks, allowing bonds to form between either side of the carbon atom. All right, so pre-20th century polymers, cotton, rubber, and silk are all polymers that have been used for centuries. In the 1800s, the chemists learned how to harden rubber so it could be used in industry, and hence tire wheels. Post 20th century saw the discovery of like synthetic polymers. So you have Kevlar, Kevlar, as you know, it's used in one of its uses is using bulletproof vests. Here's an example of a bullet trying to, it can't really pass through completely through the bulletproof vest in Kevlar. So Kevlar is used, for example, in bulletproofing, as I said before, and body armor, and there's also another compound called nylon. But in the exam, there's only two examples that you need to. There's only two examples of polymers that you need to know for the exam, and that's one of them is Kevlar, and I'll just draw the structure of it here. It's an amine group. It doesn't come up all the time, but it does come up enough time. It'll be one of those things where it's like, I knew that, I wish I had revised that, or at least just remembered it. It doesn't take a lot of time to remember. It won't ask you specifically to say it won't just say, for most of these questions in AQA, it won't just say what's the formula for this, or it will use an example, draw the polymer that will be formed when Kevlar is broken down, and you have to know this is what let me finish off actually. A benzene ring here. That's a terrible benzene ring. You might get an application question. You might get an application question where they just ask you, what is draw the structure, draw the two monomers that would make up, or draw the two compounds that when split. Trying to think of a way. So draw the two compounds when joined together can form one monomer for Kevlar. That's an example there. So it's pretty much just asking you to understand that you know what the structure of Kevlar is, and they want you to know that if I was to split this in half here, these are, if I was to get a question where they wanted me to just know this part and this part, I'd be able to do it. So just knowing this, and then everything else will come into place. So yeah, I'll just go and move on to that. And then there's another compound that you need to know, which is nylon 6,6. Nylon used in industry, it's usually just used as a fabric. You can get like cling film, which is made out of nylon as well. Nylon is, these aren't too difficult compounds to remember. Once you remember them, it'll be pretty easy to remember. So CH2, it's just hexane really. Peptide bond. Or for example, they say, draw the structure of yeah, there might be an example where it's like they say, draw the structure of nylon after it has been hydrolyzed. And in that case, say, that hydrolysis would break this peptide bond here. So you just draw the structure of it'll be hexane diamine, hexane 1,6-diamine, and a butane, or say butan 1,4-dioic acid. And then it's just, that's the point being here. You don't actually, it won't be a question where they say just draw this. They'll be asking a question where they want you to try and show your understanding by, I know what the structure of it is, and they're asking me, how does it relate to a condensation reaction? It's a two-part question. You'll get a mark for showing that you understand what compound is, and you'll probably get another mark for actually answering the question where they say, draw the structure of it when it's broken down, draw the structure of it with 3 units. That's all they're asking you usually. And then 21st century polymers, a lot of research now focuses on making biodegradable polymers. This is because now we're more aware of the danger that plastics pose to wildlife. So polypropylene is an example of a polymer. Polypropylene, it'll be just, you'd know this from GCSE here. The double bond is here. You always represent it by the you would never go on and start doing something like this. No. And then just do that there, because you can't represent double bond. You see what I mean here? So obviously your bonds extend. You have to always show your trailing bonds. They don't always ask you for the brackets, but they always ask you for the trailing bonds. So the polymers are made up of repeating units. Because of this, we can show their chemical structure as a unit, and that's repeated multiple times. The n at the bottom right indicates to us the number of this, the number of units that is repeated to create the larger polymer molecule. I think there might be a typo here. Number of times. And that's it.